Center of Nanotechnology is an advanced research service center that supports research activities in all fields related to nanotechnology. It is equipped with 18 research labs with 42 major instruments. Center of Nanotechnology is a research hub where new projects can be initiated. Collaboration in projects can be shaped, and tests and analysis can be performed. Our vision: to be partner in the sustainable growth and development in the kingdom through leading in research and localization of nanotechnology. Our mission: to be one of the best countries for nanotechnology transfer and development in the region by transferring the technology from the lab space to economical products. Also, we work with our collaborators to enhance scientific research in nanotechnology and connect university and industries in professional fields. Our objectives include organizing scientific events such as conferences and seminars in the way that service such much of the centers, the university, and kingdom in general, working towards obtaining patents and registration in the field of nanotechnology. Also, scientific publishing in the most powerful international journals, which would enhance the position of the center and university in scientific community at the global level. The center accomplishments includes more than 20 patents awarded, more than 500 scientific publications, awarded the best research center in King Abdulaziz University for 2018 and 2019, active research project with the industry including SABIC and Aramco. Also, research output ready for investment includes carbon nanostructures of oil fly ash and their applications, lubrication, water treatment, and metal oxides nanostructure and their applications, thermoelectric generator, polymers nanocomposite. Also, optical emitting materials, nanostructures of ALQ3, ionizing radiation and dosimeter, size-shaped controlled nanostructures and their biological applications, implantable nanocomposite hydrogels for bone repair, and sunlight photocatalytic, decontamination of water and water purification systems.
We at the Center of Nanotechnology welcome all kinds of cooperation with researchers, institutions, and industries. We collaborate in all nanotechnology related fields. We have research projects in basic science, engineering, medicine, and pharmacy. We also have certain projects related to certain applications, as in sensors or nano additives.
Hi, myself Dr. Zia, Assistant Professor in the Center of Nanotechnology. My area of research, main research, is sensors, and we are trying to implement the sensors in artificial intelligence. So with the availability of the large amount of data and the corresponding development in the computer technology to analyze and process them much faster and accurately than any human can do, we are going to get a magical technology that is called artificial intelligence. Artificial intelligence can mimic anything that human can do, like learning from experience, responding to languages, motions. Like we can see that now when we type, our words are being completed. We have driverless cars. So there are a lot of things that we are going to get through artificial intelligence. And when we will combine the nano sensors with artificial intelligence, it will become a big thing. For example, a human-like robot, it must have all the senses that a human has. It must have an olfactory system also. So we have a sensor array like that can detect accurately any gas. So if we make the array of a sensor and we apply artificial intelligence in that sensor, it will become gas sensor array multiplied by artificial intelligence. So with the help of this system, a robot can behave like a human. He can sense any gas, he can discriminate any gas, and he can respond accordingly. So if we see that the combination of sensor and artificial intelligence, we are going to get a big human-free automated system.
One of the most important sections in our center is the fabrication of nanomaterials in different forms and by different techniques. The first section is the thin film deposition techniques. that is used to fabricate the nanomaterials in form of a thin film. We can divide this technique to physical vapor deposition and chemical vapor deposition. Physical vapor deposition can be defined as a process in which the solid material, are vaporized under a vacuum or controlled environment to be deposited onto the surface of the substrate. While chemical vapor deposition can be defined as a deposition of a solid thin film from the vapor phase over or onto a usually heated substrate, also under a vacuum. In our center, we have different systems that belongs to physical vapor deposition and chemical vapor deposition. For physical vapor deposition, we have sputtering. We have also evaporation systems like electron beam deposition, pulsed laser, molecular beam epitaxy, and ion beam deposition. For chemical vapor deposition, we have different types of CVD like low pressure CVD, plasma enhancing CVD, and also microwave CVD. We have also atomic layer deposition that belongs to chemical vapor deposition techniques.
Now these days the researcher and scientist, we are focusing about the synthesis of nanomaterial from chemical route. Now in our center we have lot of facilities to prepare the nanomaterials. We have a system here, microwave digester system, sol-gel method, hydrothermal method for preparing the nanostructure like nanorods, nanotubes, and nanoparticles. These materials can be used in the field of medical field like sensor application and different electronics materials.
So this is the confocal microscope or laser scanning confocal microscope. So the whole idea was developed in 1950s by a scientist named Marvin Minsky. So this system can be used to acquire high resolution fluorescent images of your cells and tissues by eliminating out of focus light. So this system can be used for several applications. It can be used to image up to 4 staining of your samples. It can be used also to acquire 3D images of your sample. Suppose that your sample is thick, so you can optically slice your sample and then visualize how your molecules or drugs or nanoparticles are distributed all over the organism. It can be used also for protein quantification or protein expression as well. And it can be used also for live cell imaging, so you can have a better understanding of biological functions through the study of cellular dynamics.
I will explain you about the structural and compositional facility that we have here in the Center of Nanotechnology. Why it is important? Because most of the researchers that they are working for the different fields, they need to verify either their synthesis material is performed is good or not. For this, they need some characterizations in terms of the structure and composition analysis. Because like if we are giving some of the example, if somebody is working on the CuO, copper oxide, but it has the different phases. For that, we need to structure composition. For that, alhamdulillah, we have one of the best technique that is called the X-ray diffraction, which can confirm the phase of the material, like what is the phase like copper oxide, Cu2O, and Cu copper hydroxides. This is just an example. Similarly, after that, somebody needs to confirm the composition of this facility. There we have the EDS and XPS that can give you the information regarding the composition of the material. And similarly, if somebody is doing in the water research, we have the ICP that can know the different kind of the percentage of the material inside the water.
Science and technology always try to help the people by addressing challenges and by inventing new materials for new applications. Nanotechnology has great potential. Nanotechnology actually can invent and develop new materials from the existing ones. Here the size matters. A single element can be made into different materials having different physical, chemical and electrical properties. Chemical and physical properties of a material changes with the surface morphology and surface area. So the first step here goes to the characterization of the morphology and by morphology of the new materials that have been invented or that have been developed or derived from the existing ones. Here we have electron microscopy systems and scanning probe microscope like probe microscopy techniques. Here the electron microscopy here uses electron beam to study the surface of the sample. Here we get the microstructure of the sample, and we have here scanning electron microscope from GOL, transmission electron microscope. It's one of the advanced instrument nowadays available. The model number is ARM 200F, and we have here focused ion beam, a dual beam microscope that also uses, in addition to electron beam, ion beam also it uses. Here we can get the morphology of the sample very easily. In addition to that, we can study the elemental analysis. So we can do some elemental analysis like EDS, getting the qualitative analysis of the element present on the sample. And the topography image we can study using scanning probe microscope. And the stylus profilometer, another one machine is called stylus profilometer. That also will give you some information about the topography. The physical and chemical properties of a material changes with the surface area. Increasing surface area changes a material completely to a new material. So the characterization of a nanomaterial begins with the morphological analysis. Here we have various electron microscopy techniques and scanning probe microscopy techniques available for this. We have here scanning electron microscope, transmission electron microscope and a focused ion beam. Here an electron beam, when it interacts with the sample, produces different forms of electrons like secondary electrons, backscattered electrons, OJ electrons, etc. We can get the microstructure of the materials, and also we can do some surface analysis for elemental composition. Coming to the topography analysis, we have here atomic force microscopes, scanning tunneling microscope from Omicron and also from NanoSurf. Here we will get real three-dimensional image and real what you call the topography image. From this topography image, we can extract its the different properties of the material like the surface roughness, mechanical properties, particle and pore measurements, and also the electrical properties.
Here in the Center of Nanotechnology, we have a wide range of characterization techniques to characterize the thermal and electrical size of nanomaterials. Some of those machines are DSC, which stands for differential calorimetry, and TGA, which stands for thermogravimetric analysis, and LFA, which stands for laser flash analysis, and other machine for electrical conductivity. All those machines are designed to analyze the movement of heat, of phonons and electrons inside nanomaterials in order to give a better view about how the management of heat and electrons movement inside the nanostructures.
So in this Center of Nanotechnology, we have some techniques for the optical characterization of the systems, nanomaterials. Optical characterization is very important to know the electronic properties of the materials and its application in any optical devices. So here we have ellipsometer which gives the interaction of light with material by the change in the polarization. The detector detects the change in the polarization of the wavelength. We have a very big range from 190 nanometer to 2100 nanometer wavelength light source that detects the optical constant and each and every energy value. So with getting the optical constant that is N, refractive index and K extinction coefficient, we can detect band gap and many other properties of the nanomaterial. The most important use of this technique is that by detecting the change in the polarization, we can detect very accurately the thickness of a very well prepared nano thin films. It can measure from few angstroms to micron level. So this is a powerful technique. We have two parts in this system. One is data acquisition and another one is fitting. So by data acquisition we get the real data, and we have the software which gives the fitted value. So when the real data matches the fitted value, it gives perfectly well defined band gap and thickness of the nano thin films. Many other things, many other parameters like energy band gap and roughness we can also calculate from this system, but its major scope is that optical constant and thickness we can get from this ellipsometer.
Nowadays, nanotechnology is a very demanding field of research where new and emerging applications, they are coming by every passing day. This nanotechnology is a multi-phenomena which can be applied in different fields, and synthesis, characterization and application of these nanomaterials can be applied in various sectors. For example, electronic industry, aerospace, rubber industry and automobile industry. Especially this session has to be like designed for mechanical characterizations where mechanical strength, for example tensile testing, which can be tested by a tensile test setup in our center, and the Young modulus, hardness, elastic modulus, plasticity of the materials in the form of nanoparticles, nanocomposite, nano devices can be tested with the help of nano indentation setup in our center. That's all.
My name is Abdulaziz. I'm a postgraduate student working here at the Center of Nanotechnology. My research topic is effect of ionizing radiation on nano and microstructures of ALQ3 and its potential use as radiation dosimeter. The topic is motivated by the fact that a radiation dosimeter fabricated using ALQ3 may have several advantages over conventional dosimeter, including less energy consumption, less expensive and user-friendly. Center of Nanotechnology is often to accommodate multidisciplinary research fields, including basic science, medical science, engineering, and other relevant research fields. The center has many experts, including researchers and technical experts. The experts here are well-trained with vast experience. They are also friendly and easy to interact. I therefore urge my fellow postgraduate students within KAU and outside to patronize the Center of Nanotechnology with a view to utilize the numerous instruments and services such as nanofabrication and nanocrystallization.
I am Humair Hussain, PhD research scholar. Doing research is my passion, and I am thankful to King Abdulaziz University who offers me such a great opportunity. I am working on CDI, a most promising and novel technology for desalination. Here our team is looking for a new and advanced technique for desalination. For that, we are designing a carbon electrode with good surface area, porosity and conductivity. This center has advanced and updated tools under one roof. Pulse laser deposition, chemical vapor deposition, SEM, TEM, Raman spectroscopy, and many more, which is useful for all science fields like physics, chemistry, medical sciences. I think this center is a very good platform for young research scholars and scientists because the professors here are very cooperative, always encouraging and helping the student. As an international student, working here is an awesome and joyful experience because advanced technology and the friendly attitude of the university.
Our services include fabrication, characterization, and analysis of nanomaterials. We also provide consultation services. For direct services, you can contact the center through our website. where there is a portal to include all information needed to provide the service. Then we will follow up with you through email. To collaborate with us for all other services, you can contact the center through phone, email, or website to arrange for a meeting, and we will take care of you from there. We can do different type of collaborations on research and development projects. We can collaborate by doing the direct service only, or doing a complete task in your project, or initiating a joint new projects together for nanotechnology.